Good morning. Just thought I would give you a quick review of the first two parts of Module 7, 7.1 and 7.2, and there was a request that I do that by going through some of the practice questions from within the assignment booklet itself. Now, I know that you guys already have the solutions to that. Remember, it's in the appendix of the module itself, which was posted on Google Classroom. But sometimes it's nice just to see the actual problem being solved. So I hope this does you some good. Anyways, let's start. So this is 7.1, the first practice section of 7.1, and we'll get started. So 7.1 deals with the slope-intercept form of the equation y equals mx plus b. Remember, m is the slope, b is the constant term. Remember, that means the term that doesn't have a variable attached to it. And in this case, b is the y-intercept, the place where the line crosses the y-axis. So for the very first question, which says state the slope and y-intercept of the following graph, explain how you determined each. Well, if you have a graphed line, the y-intercept is really easy. The y-intercept is simply the point where it crosses the y-axis, okay? And for this particular one, it looks like it's a little bit above 7, so let's just say it's at about 7.2, okay? Again, you know, in a question like this, I would allow a little bit of a range for the answers because it's kind of hard to tell from this. But we'll say the y-intercept is 7.2, okay? Now, to find the slope, it's not quite as easy. We have to use the slope formula, okay? And remember, the slope formula is slope equals y2 minus y1 over x2 minus x1. Pick 2 points on the line. Any 2 points will work. Okay, so remember that. Any 2 points will give you the slope. So pick points that are, you know, fairly close to being at an intersection of grid lines. So I'm going to pick this one, and these all look about the same, and I'll pick this one. Okay, this one here looks to be at 6 across and 6 up, so 6 and 6. And this one here looks to be at negative 20 and positive 11. So negative 20 and positive 11. These are the points that I'm going to plug into my slope formula. So y2 minus y1 becomes 11 minus 6. x2 minus x1 becomes negative 20 minus 6. And that gives us a slope of 5 over negative 26. Okay? Now, remember I said if you get a fractional slope, leave it as a fraction. Okay? And also, I always move the negative sign up. So this can also be written as negative 5 over 26. Okay? So our slope is negative 5 over 26. Okay? That's the first one. So, there we go. Now, this next question, question 2, says, write the following equations in slope-intercept form. And remember, slope-intercept form is this one up here, y equals mx plus b, which basically means whenever you're asked to write an equation in slope-intercept form, what they're really saying is isolate y. Okay, get y all by itself, usually on the left side, although it doesn't matter, but get y all by itself by moving everything else to the other side. So you see in the first one here, all we have to get rid of is 6 because it's added. Remember, we always do the opposite operation to both sides, and that gives us y equals 6 minus 6 is 0, 3x minus 6. Done and done. For the next one, we'll skip the next one. We'll do C. So for C, again, we have to get y all by itself. It's just there's a little more work to do, right? Because there's more stuff. So we have to get rid of the 22, and we have to get rid of the 3x. Both of those involve subtraction, so we can do it all in one step. We can say, well, I know I have to take away 22 from both sides, and I know I have to take away 3x from both sides. So 3x minus 3x is 0, 22 minus 22 is 0. That leaves us with 12y equals, and I'm just going to put this in the y equals mx plus b order, so I'm going to write it as negative 3x minus 22. Okay? We're not done. We still have to get rid of this 12. Now, this 12 is attached to the y by multiplication. We don't want to move the whole thing. We just want to get rid of the 12. We want to leave the y there. So, in order to separate these, we have to do the opposite operation, which is division, and we're going to divide by 12. Remember, when you multiply or divide, you have to do it to every single term. Okay? So, 12 divided by 12 leaves us with 1y. Negative 3 over 12 can be written more simply as negative 1 over 4, right? We divide the top and the bottom by 3. X minus 22 over 12 can be written more simply as 11 over 6. Okay? Again, usually it's better to leave these things as fractions. Okay? If it simplifies to a terminating decimal, or better yet, to a whole number, go ahead and change it. But there's nothing wrong with leaving it the way you see it on the board. Okay? Number 3. Consider the slope-intercept form of a linear relation y equals mx plus b. Explain how this form can be used to graph a relation by hand. So this is kind of like question number 1, in that we can take advantage of the fact that we know the y-intercept, right? The y-intercept is our b value, and we know the slope. So we can plot the y-intercept, b, and that will give us a point, okay? And then, to get a second point, and remember you only ever need 2 points to graph a linear relation. So you plot the y-intercept, that gives you 1 point. And then use the slope to get to your second point. Remembering that the slope is the change in y over the change in x. So for example, if I had a slope of 2 over negative 3, that would mean my change in y is positive 2, so I would go up 2 from my y-intercept, and my change in x is negative 3, so that means I would go to the left, right? Because to the left is towards more negative things along the x-axis. So left 3. So that's how I would graph this relation by hand. And this is what we're going to do right now, okay? So it says graph each of the following. So I'm going to do this fairly quickly. So here's my y-axis, here's my x-axis. And remember, the origin is always at 0 and 0, so that means we go 1, 2, 3, and so on, -1, -2, -3, and so on, 1, 2, 3, -1, -2, -3. Okay? So to graph this, we first plot the y-intercept, which remember is the point where the line crosses the y-axis, so that's at 4, 5, 6, 7 right here, and the point is 0 across and 7 up. And then we use the slope, and I'm just going to write it over here, 3/5. We use the slope to get to the next point. Okay? Oh, this isn't going to work. Oh well, it'll work well enough. Anyways, our slope tells us, remember this is change in y over change in x. Our slope tells us that our change in y is to go 3 up. Our change in x is to go, and because it's positive, this time we'll go to the right, so 5 to the right. So you can see what I meant when I said this isn't going to work. We have to go 1, 2, 3 up, and we'll make believe that's there. Okay, we'll just extend our line, and so that means it's at 10, right? 7 plus 3 is 10, and then we go 5 over, 1, 2, 3, 4, 5, and that brings us to this point right here. Just let me get rid of some of this mess here. So our second point then is at 10 up and 5 across. So 5 across and 10 up. There's our second point. And again, remember, if it's a linear relation, once you have 2 points, you simply join them with a ruler. And there's your line. Okay? So that's how you graph a line if you have your equation in y equals mx plus b form, in slope-intercept form. This one is exactly the same. It is in slope-intercept form. It will have a slope of -40 and a y-intercept of 200, so why don't we do it? So very quickly, there's our y, there's our x, and I'm going to go up by 20s just so that it'll fit. Okay, so again, remembering the origin is at 0, here's your x, here's your y. If I go up by 20s, that means 20, 40, and so on, -20, -40, 20, 40, -20, -40, okay? So, our slope is -40 over 1, okay? Slope as a fraction allows you to find that second point. Our y-intercept is at -200, so that means we're going to go 20, 40, 60, 80, 120, 40, 82. Okay? So there's our slope at, there's our y-intercept at 0 and -200. Now we use our slope, which is -40 over 1. That means we are going to go 40 to the left. Sorry. I bet you could tell it's Monday. Since this is our delta y, our change in y, we're going to go 40 down, and we're going to go 1 to the right. Okay? So, oh gracious. Tell you what, just so this will graph, we're going to put the negative down here, and you can do this. It means you're going to go 40 up, and then you're going to go 1 to the left. Okay? So 40 up would bring us to minus 180, minus 160. So negative 160. And 1 to the left will bring us just a tiny bit to the left. Okay? So that means we're going to go up 40 and 1 to the left. And there's our second point, which will be at -1 and -160. Okay, so there's our second point, and that's going to give us an incredibly steep line, which shouldn't be a surprise, because look at the slope. The slope is 40. Okay, so that's going to give us a line that's going to look something like this. Continuing along. Explain how technology could be used to check your graphs from question 3. Now, in the module, it shows you how to use your graphing calculator. This is something that we're not going to spend really much time on because of our COVID Math 10C class. It doesn't allow me to be with you to help you to set up your calculators to graph equations. But use your graphing calculator now. Since most of you are going to be taking Math 20-2 next year, you're going to get tons of practice doing this next year, so don't worry about it. The graph of a linear relation with a slope of 5.8 passes through the point -2, -5. Determine an equation for the relation in slope-intercept form. So, what are we missing here? For slope-intercept form, we need to know the slope. We got that, it's 5.8. And we need to know the y-intercept, but we don't know that. However, if you look at your formula, y equals mx plus b, they've given us the slope, 5.8. And look what else they've given us. They've given us an x coordinate. We can plug that right in there where you see x. And they've given us a y coordinate. We can plug that right in over here where you see y, and then we'll have an equation that looks like this. Instead of y, it's -5, right? Instead of m, it's 5.8, and instead of x, we sub in -2, and we're left with an equation that only has one variable. Awesome. If we only have one variable, all we have to do is simplify the equation and we can get a value for b. I'm just going to grab my calculator. And I'm back. So, 5.8 times -2 is -11.6. So -5 equals -11.6 plus b, and then to isolate b, we simply add 11.6 to both sides. Minus 11.6 plus 11.6 is 0, that leaves us with b. -5 plus 11.6 is 6.6. So our value for b, for the y-intercept, in other words, the point where the line will cross the y-axis, is at 6.6. That gives us enough information to answer the question. Because remember, if we know the slope and we know the intercept, we can say the equation for this line is y equals the slope of 5.8 times x plus our y-intercept, which we found here. and you're done. Okay? Now, this one says, explain how you can use the equation y equals 4.592x minus 8.387 to determine points on the corresponding graph. Now remember, with the exception of perfectly vertical and horizontal lines, you can substitute any value for x and then get a corresponding value for y. Remember, that's how you make a table of values. Okay? Now, being as it's a linear relation, we only need two values. Okay? So I would suggest that you use values of 0. Okay? So let's say if x equals 0, what does y equal? Well, we just take our equation, we substitute a value of 0 for x, so it becomes 4.592 times 0 minus 8.387. Now, the reason I said use 0 is because that makes your life a whole lot easier, right? Because you know when you multiply these together, you're going to get 0. So y equals minus 8.387. That gives us our y value, 8.387. Okay? Now we can do the same thing by choosing a y value of 0 to find a second point. Okay, so this time, choosing a y value of 0 and subbing it into our equation will give us a y value of 0, and now we have an x value which we have to isolate. Okay? Now that makes life a little bit more difficult, but we can still do it. Okay? We want to isolate x. That means we're going to add 8.387 to both sides. That will give us 8.387 equals 4.592x. And then our last step is to isolate x so that we have an x coordinate here. We divide both sides because we're multiplying here, so we have to divide to get rid of it. 4.592, 4.592. Thank goodness we have a calculator. This divided by this will leave us with 1x. This divided by that will give us 8.387 divided by 4.592. 1.826. 1.826, which becomes our x value. Now remember, this will give us two ordered pairs. The first ordered pair, 0 and 8.387, we can plot that. The second ordered pair, 1.826 and 0, we can plot that. Once we plot those 2 points, just get a ruler, join them up. Okay? State 3 points that could be used to graph the relation, blah, 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 blah. Well, we've already got 2 of them. To get a third one, you simply pick another value for x, we'll say 1, and you would sub it in where you see x and solve for y. That would give you your third point. Okay? A plumbing company installs tankless hot water heaters and charges for both installation time and materials used. The heater and supplies cost $1,800. The shop charges $110 per hour for a plumber and an apprentice. Write an equation to represent the total cost to the customer. Be sure to state what each variable represents. So, the first thing you need to do is think about this. Remember, in a linear relation, we have an independent variable, or x, and a dependent variable, or y. So you have to ask yourself, we have two unknowns, the total cost and the number of hours this plumber is going to take to install the hot water heater. Which one is the independent variable? Which one is the dependent variable? Well, the amount of time it takes him to install is a time. Anytime you have a time, it's going to be your independent variable. The total cost is dependent on the amount of time it takes to install. Okay? So, that being said, we have one other number, that's the cost of the heater and supplies. That doesn't vary. It's going to be $1,800 whether it takes the plumber 1 hour to install it or all day to install it. The cost of the heater is going to be $1,800. So that is our constant term, or our y-intercept. So in slope-intercept form, y equals mx plus b, it becomes total cost, or y, equals the slope, which remember is the variable part, $110 times the number of hours it takes plus the cost of the heater. Okay? What is the slope of the relation? $110 per hour. What is the vertical axis intercept, or y-intercept of the relation? Remember, that's the constant term, the one that doesn't have a variable. In this case, $1,800. Sketch a graph of the relation. Well, I'm not going to bother doing that one because we've done lots of these already, right? You're going to draw yourself a coordinate system, a y-axis and an x-axis. You know that it's going to cross way up here somewhere at 1800, that's your y-intercept. And you know to get to a second point, you have to go 110 up and 1 to the right. So use the slope to find your second point, and then just join the points. Okay? If the installation takes 2 hours, how much will the customer be charged? Well, let's erase this. So again, our equation is the total cost, y, equals 110 times the number of hours plus the cost of the heater. There's our equation. They're telling us it takes 2 hours. That's our x value, remember, our independent variable. So to find the total cost, we simply go y equals $110 per hour times the 2 hours it took to install plus the cost of the heater. Y equals 220 plus 1,800. Y equals $2,020. If a customer was charged $2,185, how long did the installation take? So this is simply giving you a value for the total cost, your y, and asking you for your x, the number of hours it would take. So again, take your original equation, and this time the value they're giving us is a y value, the total cost, so it goes in over here. $2,185 equals 110x plus 1,800. Isolate the variable. So we're going to take away 1,800 from both sides. There it will cancel, leaving you with 110x. On this side, we get $385. Okay? Last step, get rid of the 110 by doing the opposite operation by dividing. I did it again. It is such a Monday. So 110 divided by 110 gives us 1x. 385 divided by 110 gives us something. It gives us 3.5. So, how long did it take? It took 3.5 hours. Okay? And that is it. I think maybe what we'll do is we'll do the 7.2 practice problems tomorrow, because this is already a 30-minute video and I try not to make them last any longer than that. So, have a lovely day. I hope this helps you with 7.1, and we'll do 7.2's practice questions tomorrow. Bye.